Now I have those columns here. So now I want to reduce this address a little longer. I mean a little shorter. So I can do this. 2001 colon. I can put colon. Look at this. Okay, don't worry. AD colon 1. Good guys. So now this is a wrong way. You cannot use this format. Okay, this is a very bad one that if you do it, it means you are getting everything all wrong. This is completely unacceptable. That one. This is not acceptable. So you cannot use this format. Okay. All you can do, you can have a leading zero at least once only. Okay. You cannot have it more than once. Okay. So if you have it more than once, a double colon in an address more than once is unacceptable, because the router or the devices will not know how many zeros or how many hex that are part here and how many hex that are here. So it will be completely difficult for the router or the host to understand. So in that case, you have to maintain one side of the consecutive zeros and then omit the other side of the consecutive zeros. So right now we have 3 here, so I can omit those 3 right from there. Okay. So in that case, I have to maintain those these 4 zeros right here. So I cannot use the colon 2 times. So I have to maintain this 0. Okay. So I have to omit these zeros, and then I'll represent them with like here the 0 will remain. Here also the 0 will remain. Here AD will remain. So here I'm gonna represent with a double colon, and then after that I have a 1. So this is basically how you're gonna do it, because these zeros have to remain the way they are, because they are consecutive obviously, but you have another consecutive zeros here, so you cannot have 2 consecutive zeros at the same time. That will affect your configuration, so it cannot happen. So I hope you guys understand this one, so you can practice it all the times. Make sure that if you have leading zeros, you omit them. You're left with 1 0 if you have 4 zeros in a hex set. If you have 2 zeros and a number, a valid number, I call them valid numbers. From 1, 2, 3 up to 9, and from A to F, I call them as valid. But if they are zeros, they are zeros, so they are not important. So in that case, you can reduce this address in this format. Okay, so I will continue. We have Ipv6 address types. We have unicast, multicast, and anycast. So like I explained, there is no more broadcast address for Ipv6, but we have unicast, we have multicast, and we have anycast IP at version 6 addresses. So we have to be a little careful with that. So the unicast is similar to that of the single course version 4 address. We have the multicast that is used for 1 to a group, and then anycast 1 to the nearest, and I explained this one in my previous video. Anycast is not as broadcast, because broadcast is a message that is sent to all the devices that are in the local segment, but anycast is a message that is sent only to devices that are nearer. Okay, that will receive this one. So we have prefix length and the address type format of Ipv6. Ipv6 uses what we call prefix length, not CIDR, not anything else, or slash notation. It uses a prefix length, and that prefix length tells how many bits are part of the network and how many bits are part of the host person. Because Ipv6 also have both ones. You have the host person and you have the network person. So the first 64 bits represent the network, and the last 64 bits represent the host. And the first 64 bits is called the prefix length, and the last 64 bits is called the prefix, and the last 64 bit is called the interface ID. So that's why you call it the network is the prefix, and the interface ID is the host person. So Ipv6 address has the unicast. We said Ipv6 has unicast, multicast, and anycast. The Ipv6 unicast address comes in different forms. It has global unicast, link local, loopback, unspecified address. We have the unique local, and we have the embedded. The most important addresses in this are the global unicast, that is similar to that of the public IP. The link local is the address that is used by devices in a local segment to communicate with each other, and the unicast or the unique local is like the private Ipv6 address. So these are the the most important IP addresses that are in the global IPv6 unicast addresses. So the link local IPv6 unicast address, like I explained, is used within a local segment and is used by devices to communicate within the local network. But this is not usable outside of that local network segment. But in IPv4, devices must have the same network address before they can communicate. In IPv6, they can communicate without being in the same network, but they use the link local address to communicate with each other. Alright, so the structure of an IPv6 global unicast address is this way. So you have that's how it looks like. From 001 to 200/3 are being assigned for the global unicast address, and the global routing prefix network portion of the network address, or of the address that is assigned by the provider, is typically 48-bit. So you can be asked in an exam, the global routing prefix is what? It is 48 bits. Global routing prefix is 48 bits for IPv6. The subnet ID is used to subnet within an organization, just like subnetting is done there. So the 16 bits is main for subnetting, and the last 64 bits are for interface. So it's the first 64 bit that is divided into two: global routing prefix and subnet ID. So that is exactly what they're trying to explain here. So that's how you do the configuration. I will take you guys through this configuration in our previous in our next subsequent videos. So we have dynamic configuration. IPv6, you can do some configurations with it for DHCP, so devices can obtain IP address from a DHCP server on IPv6 very easy and quick. So what it does is using stateless address auto configuration that is slack and short. A device can obtain its prefix length, default gateway address, and other information from an IPv6 router. It can also use router's ICMP router advertisement message to obtain its type. So we have two: router solicitation message and router advertisement message. A router solicitation message is used by a PC that is on the network to request for IP address from a router that is on the network, or IP address information or from a device on the, from a router on the network. And the router responding given IP addresses is the router advertisement message. So there are three options that IP address can be assigned to a device automatically in an IPv6 environment. We have option 1, slack only, that is a router given IP address, or you can have both option 1 and 2, that is a router giving some part of the IP address to the PC, and you have a dedicated DHCP server also on your network that can also be providing IP address to devices in your network. So option 3 is that the devices will ignore every configuration assignments on the router, and then they just take the IP address information from a DHCP server assigned to them in their network segment. So we have one thing that we call the EUI64. The EUI64 is extended unique identifier. It is used in an address to provide to make the address reach 64 bits maximum, because MAC address of every device is 48 bits. So in order for you to extend it to be an IPv6 address format to get 64 bit, you have to insert 16 bits in the middle of the 48 bits. So first three how to call it, hexadecimal digits in between them, and the last three. So you have to put this 16 bits in the middle right there, and those 16 bits is FFFFE. So the FFFE should be inserted in the middle of your MAC address.